Hey, hi, welcome here. My name is Adarsh Patil. Welcome to the Learn Logic channel. In this channel, we are posting videos related to 11th and 12th science stream students. We are having currently series of chemistry, and in this video, we'll discuss the atom and its constituents, that is proton, neutron, and electron. And in the last point, we will discuss the difference between each of these particles. Let's start with the content. First, atom and its constituent particles. An atom is the basic building block of matter. It is the smallest unit of an element that retains the chemical properties of that element. Atoms consist of a nucleus made up of protons and neutrons surrounded by electrons that orbit the nucleus. Here in the left hand side video you can see the yellowish region, that is nucleus, which has protons and neutrons embedded in it, and outside of that nucleus the electrons are revolving around it. First particle, that is electron. Electrons are negatively charged particles that orbit around the nucleus in specific energy levels or electron shells. They are much lighter than protons and neutrons and contribute to the atom's overall negative charge. The relative charge for electrons is -1 as compared to neutrons. The number of electrons in a neutral atom is equal to number of protons. This statement is very important with regard to MCQ exams. Number of electrons and number of protons for the electrically neutral atom is equal or same. Let's discuss the another particle, proton. Proton are positively charged particles found in the nucleus of an atom. Each proton carries a charge of +1 and contributes to the atom's overall positive charge. The number of protons in an atom's nucleus is what determines its atomic number, and different elements have unique number of protons. Since after experimentation it has been found that the number of protons is different for different elements, and each element has a unique number of proton. Therefore the term atomic number is made with regards to the number of protons in that particular element. Next particle, neutron. Neutrons are neutral particles also located in the nucleus of an atom. They have no electrical charge, meaning their charge is 0. Neutrons help stabilize the nucleus by counteracting the repulsive forces between positively charged protons. The total number of protons and neutrons in the nucleus is known as atom's mass number. As discussed in previous slides, electrons are very light than compared to protons and neutrons. Therefore, the total number of protons and neutrons, when they add up, form the atomic mass number. Here in the upper figure you can see the size variation of particles or constituents of an atom. Let's discuss the size variation in terms of their diameters. First, proton diameter. The diameter of proton is in the order of femtometers. It is typically considered to be around 0.84 femtometers. Note here, 1 femtometer equals to 1 into 10 raised to minus 15 meters. Second, electron diameter. Electrons are often treated as point particles, meaning they have no measurable size or volume in classical terms. Therefore, their diameter is not applicable in conventional sense. If we try to compare the sizes of electron and proton, then we get to know that one size of one proton, that is diameter of one proton, is equal to 1000 times the diameter of one electron. Third, neutron diameter. Similar to protons, the diameter of neutron is also in the order of femtometers. It is approximately 0.88 femtometers. Okay, here you can see the small change in the size of neutron. Fourth, nucleus diameter. Diameter of nucleus is on the order of femtometers as well. It can vary depending on element and isotopes, but it's typically within the range of 1 to 10 femtometers. And the last, the first electron orbit, also known as Bohr radius, is a fundamental constant in atomic physics. It is approximately 0.529 angstroms. Okay, that is 0.053 nanometers. Note here, 1 angstrom equals to 1 into 10 raised to minus 10 meters. And the last point, difference table. Here we will discuss the difference between electron, neutron and proton. Symbol of representation for electron is small e, for neutron, that is N, and P for protons. Charge: electrons have negative charge, neutrons are neutral, and protons have positive charge. Relative charge: -1 for electron, 0 for neutron, and +1 for proton. Electric charge: it is a value of negative of fundamental unit of charge for electrons, neutral for neutrons, and positive value of fundamental unit of charge for protons. We'll discuss what is the fundamental unit of charge in the next slide. Next point is location. Electrons are found in the electron cloud surrounding the nucleus, whereas neutrons and protons are found within the nucleus. Approximate mass in kg. Electrons have mass around 9.11 into 10 raised to minus 31, and protons and neutrons have around 1.67 into 10 raised to minus 27 kg. Relative size. Electrons are extremely small, neutrons are similar in size to protons, and protons are larger than electrons. Relative mass. Electrons have very less mass as compared to the protons and neutrons, and thus proton and neutron are considered to have one atomic mass unit each, one particle. Role of these particles. Electrons are involved in chemical bonding and electricity. Neutrons stabilize the nucleus by counteracting the repulsive forces between protons, and protons contribute to atoms' identity and chemical properties. Let's discuss the fundamental unit of charge. The fundamental unit of charge is the charge of single electron or a single proton. It is denoted by symbol E. The magnitude of this elementary charge is approximately 1.602 into 10 raised to minus 19 coulombs. The unit of charge is coulombs, and it is denoted by capital C. Here we come to end of this video. Thank you. Jai Hind. Stay tuned for the upcoming videos of series for chemistry, where we will be discussing the fundamental points related to such parameters. Thank you.